Hi, I'm Jay Chogat, Senior Editor of Clean Trucking. I am at IAA 2024 in Hanover, Germany, and next to me is the Windrose all-electric semi-truck.
Hi, I'm Jason Roycht. I'm an advisor for Windrose and happy to tell you about our truck. So what we're looking at right here is the first prototype of the European spec for the Windrose truck. This truck is one of only 2 trucks that are ground up battery electric trucks here at the IAA show. This truck and the Tesla truck are the only 2 that haven't been designed to accommodate a diesel engine. So it's a purpose-built frame around the batteries and a very aerodynamic front end cab. What makes this truck different and for the European specs are starting with the back. There's a single axle in the back. This is the mainstream spec for Europe. We also have a sleeper cab, which is a requirement for a long distance haul in Europe, as well as mirror camera systems, which are, according to the legislation here in Europe, the standard that you'll see on all of the longer range trucks.
But we don't have them in the United States.
Right. The United States and Canada are right now currently the only regions that do not allow these in operation. We hope they eventually will, because you can actually calculate the amount of CO2 traditional mirrors waste via aerodynamic inefficiency. So typically we're talking about maybe a 5% improvement, and that's really large when you talk about trying to maximize every kilometer for every kilowatt hour of energy.
They're going to be conventional side mirrors in the United States.
The first ones will initially have conventional side mirrors. We're discussing maybe to keep some of the cameras because they improve the safety and the visibility on all operations. But yes, there is a way you could actually retrofit the cameras in after the initial vehicle is sold. We'll see how that develops, and if it's worthwhile for customers to pursue or not.
Okay, so let's step inside.
Yeah, let's do that. So what you'll see is a tremendous amount of space in here, a lot more space than a traditional diesel planned truck, mainly because we are pushing the driver close to the front. There's nothing in the way of an engine. A lot of people ask, well, why did you decide to put a single seat in? But if we notice this windscreen, it's not as wide as a traditional diesel, because if we look at the truck from the top down, it's coming to a little bit of a point for aerodynamics. So with that, we're faced with a decision. If we want to have 2 seats, then we would have to move them back here to have space for them. But then we would have a tremendous dashboard in front of us and, frankly, wasted space. So the logical conclusion is to move the seat forward, and then 1 seat is really all you need. So this configuration gives us the optimal interior space. What you'll see, the basic driver information system, there's 2 screens on either side. There's a digital dashboard right behind the steering wheel that is customizable for what's there. We also have a heads-up display for speed and battery range. In addition to the 2 main screens, you'll see 2 additional screens up here which serve as the digital mirrors replacing the physical mirrors. And they're approximately in the same location the drivers are used to looking anyways, and you'll see multiple views on the camera. One of the neat features here is that they will adjust when the steering angle of the trailer moves. So for instance, if the truck is making a right turn and the trailer starts to block the view, the cameras will automatically adjust to show what's there and not just the trailer as it's turning. So there's software enhancements that are built in that can detect that and adjust. We also have the ability through the multiple cameras to have a different point of view in reverse versus a different point of view on the highway. So these things can all be programmed dynamically in. It's really a much better setup all around, and that's partially why the rest of the world has really adopted this, for the fuel savings or the energy efficiency as well as the improved safety.
Okay. What's this right here? Is this just a screen, and this is just like kind of like a...
No, it's actually a big moonroof. Several reasons for that. It could, in the case of a tip over, become an escape path for the driver. We want to make sure that we have multiple areas for that. And yeah, what are you going to do with this space anyways? You might as well make it a little bit interesting. And then what you can see behind us is a full sleeper bed, storage for what a driver would need, entertainment. We just have a television in this one. And then we still can, with this setup, have a jump seat for additional driver or additional passenger. This configuration is really what I would call the standard for what European drivers are expecting for longer haul. With more than 600 kilometers or 400 miles, that's a typical long haul range in Europe, and this is the exact interior that the European driver would expect.
Is this basically the layout that will be coming to the US for the interior?
Yes, we're going to initially bring this layout, but we will evaluate as we go forward. Does it make sense to lose this area? Do we really need it? We may offer it without the full bed, of course, without the television, and try to make more use of this space.
Okay. You look cool. That's all you have to do.
Yeah, so that's the door setup. It is an automatic door. It's helpful for the driver when he's in the seat, or when the driver's in the seat, they can push the button and already the door is starting to open. Just saves a little bit of time,
There's only one door on one side.
Yes,
correct?
this design has one door on one side. We have the ability to put two doors in or a door on either side, again, depending on the market conditions.
I'd say.
This is kind of one of the main unique things about the European market. Because of the way the trailers are set up and the axle loads, most of the European freight market is driven by what we call a 4x2 design, which is basically one axle in the back and one set of four tires in the back. Provides a little bit of an advantage on the overall length of the tractor as well as the trailer. It makes us redesign a little bit how we treat the electric axles. So the US and China and several other parts of the world are going to have two driven axles in the back, whereas this one only has one. So we have to put slightly bigger motors on that back axle. But this is all incorporated in our approach with the axles.
And what batteries is this running here?
This particular one has LFP batteries. Because we have a unique frame setup that is basically going around the batteries instead of the batteries being attached to the sides, we have the ability to use slightly different dimensional packs inside. So what we've prepared to go to market with is LFP packs as well as NMC packs. Okay. And the main trade-off between the two that is important to our customers is weight and life cycle. So LFPs have a much longer life cycle than NMCs, but they also weigh a little bit more. And there's some cost differences as well, but the main driving features for the customers are weight and lifetime. And lifetime is important for useful life of the asset, residual value. A lot of customers are financing these things. Mm-hmm. So having batteries that last 50% or longer more increase the value of the truck over time and make a much better economic proposition. One of the other things that's unique about our truck is we have a charging port on each side. And because we're a global company, we are adapting to many different charging standards. CCS, which is kind of the predominant standard right now, MCS, which is a megawatt standard, which has a different connector, and then there's an Asian spec, CHAdeMO, that you'll see here. One of the neat things, though, with the Windrose truck is we do have a charge port on each side, and this allows us to do several different things. As the industry goes from CCS charging to megawatt charging, we're going to have a period where customers are going to have to decide which standard do I want. It's kind of like the difference between USB-C and older USB. So we actually have the ability to put one of each of those on. The other interesting thing we can do is we can double up the same charging connection, and that allows us to charge twice as fast on existing CCS architecture. So if customers have a bank of, let's say, 180 kilowatt charging, they can come in and in an opportunity charge, they can hook two of these guns up and actually charge at 360. And then the math is quite simple from there. So, you have 175, 180, 200, some cases 400. So with two 400 kilowatt chargers, you can actually get up to 800 kilowatt charging without the new MCS standard and without the liquid cooled charging. Just provides a lot more optionality to customers. So this is the more traditional double axle setup. We call it a 6x4. So there are two driven axles here. This configuration here has two motors on each axle. We are developing a tri-motor setup that has a axle for basically cruising with one motor on it, and then two motors supplementing the power when required. That overall gives us even better efficiency. And if we come over here, we can see the covers are off, and you can see what's unique about the frame style. So most of every other truck on the road today has what's called a ladder frame, which is two big, large pieces of steel that you'd see here that basically continue from the back all the way to the front of the truck. And in this configuration, how most people have approached it is they've put batteries on each side of those frames, and in some cases in the middle. But what we've done at Windrose is we've taken a completely different approach, what I would call a ground up approach. So you'll see our frame ends being a traditional style right about here, then it expands out and around and provides a large amount of real estate to efficiently package a large amount of energies. And this allows us to put larger packs in that are more efficient for cost and more efficient for cooling and more efficient for weight. So we have two banks of battery packs. In this configuration, there's actually four, two stacked on this side, two stacked on that side. That's our LFP design. And our NMC design actually has 3 packs on each side. And we're able to swap out when we make the truck between the two and have the same center of gravity and nearly the same performance. And this allows us to be adaptable as battery packs. Either we want to localize them or as we find more competitive solutions, we're just way more flexible with this setup.
So what kind of mileage are you seeing so far?
With the 730 roundabout kilowatt hours, we can easily go 420 miles range on it. And all of the testing so far and all of our piloting is being done in China. And in China, the load limit is a lot higher than the US and Europe, as a matter of fact. It's 49 tons or roughly 108,000 pounds. So we do all of our range testing at those limits. And what we find is when we reduce the combined weight even lower than that, our efficiency gets even better. So we've had runs already where we've done close to 425 miles and still had a third of the battery capacity available. So, it's also part of the physics of a very aerodynamic and slick design. The lower weight we go, we can optimize the energy consumption at a constant rate. And, the Tesla guys are familiar with this too, but everybody else who hasn't started testing with this type of setup, this is kind of a new phenomenon.
So do you have pricing ready to go yet?
We're still working on the pricing. I think that one of the main challenges for electrification around the world right now is simply a cost structure that doesn't make sense. The trucks cannot cost 2 or 3 times as much as their diesel equivalents and rely on a potential offset of electricity or maintenance. It just simply hasn't opened it up. And the market has focused around subsidies and subsidized markets. What we believe is that there is a sweet spot in the price that is lower than what it is today, still maybe a little bit higher than diesel, but somewhere south of the $300,000 range is where the sweet spot is. We're very confident we are going to have a substantial price advantage to the current state of the art.
So when can we expect this in the United States?
So we are very excited that we are going to start piloting fleets with customers in January of 2025.